Hello everyone. Today's topic is indices and surds, and logarithm maybe we will doing later. This topic in indices, what we have to remember like before doing indices. In indices, we should know the laws of indices first of all. What are the basic laws? First, we will say when the in multiplication when the bases are same, the powers will be added. Powers, exponents will be added. Uh, this is also helpful in mathematics as well as in maths. Example is here like suppose a power is 5 multiplied by a power is 6 multiplied by a power is 3 multiplied by b power is 2. Same basis should be there, as we know that's a to a cube, where a is called the base, 2 is called the constant term or the coefficient, or we can say the coefficient, and the 3 is called the power, exponent, or also the index we can say. On and base we can say also the variable. Okay, when the same basis, so when the same basis a power will be added, so power will be 5 plus 6 11 plus 3 is 14, but b will remain same. We cannot add b. Second law, we can say the power to power is multiplied. Power to power is multiplied. This we can say like one example I can take x power is 2, the whole power is 3. So this will multiply 2 times 3 is 6. The whole power, so power to power is multiplied. Rule number 3, the law. The whole power is the power to all. The whole power is power to all. Actually, these are my statement to explain my students in the class. So the whole power is the power to means x power is 2, y power is 3, z power is minus 2, and the whole power is about 3. So this 3, the whole power is power to all, and power to power is multiplied. The final result will be 6. 3 times 3 is 9, and minus 2 by 3 is minus 6. This is okay. When the bases are same, the power will be added, and as well as when we have, like suppose I will give an example here. A power is 5 divided by a power is 3. So when I move from the denominator to up, move down to up, or up to down, we will change the sign. So this is 5 minus 3, and the answer is 2. Okay, we should move the next part. Whole power is the power to all power we have done. Okay, then we have as well as we can see the questions from the book. This is ADMAS Singapore edition publication for the Asian Singapore publication, exercise 3.1. Without using calculator, evaluate the following. This is okay. I would like to also write this. Whenever you have x power is 0 is always equals to 1. 1000, 10,000, or whatever the power is 0 is always equals to 1. Just remember, don't forget it. Okay, this part we are doing the first part. The first part is the whole power is 0, so we don't need to simplify, just give the answer 1 given the a part. Okay, bases are same, power will be added. So what we can do in b part? In b part, 8 bases are same, so we can write 8 ones, 1 upon 2 and 1 upon 6 we can add it, and then we can add like this is ADMAS, and in this question we are not allowed to use calculator, so you can use uh, 2 and 6, when you take the LCM, normally you should know. I want to show you. Through 2 times 3 is 6, then this will multiply by 3, so it's 3 plus 1, and this is 4 upon 6. When you simplify, it's coming 2 upon 3. Okay, but you can still simplify. Like, what is the 8? Like, how can you make the power of any number to get 8? This 2 power 3 is 8. And 2 upon 3, this 3 and 3 cancel out. You can cancel. And the result is coming just 2 power 2, and answer is 4. We've done it. Okay, this C part. The whole power is the power to all. I told you in my explanation, the whole power to power is multiplied, the whole power is power to all. Okay. This 4 is a power on 2, and this 4 is power on under root 3. Okay, this under root 3, when we write irrational numbers with root, this is also called the surds. That's the irrational roots, the topic of surds. So 4 is a power of 2. We can write 2 power is 4, and under root 3 is also having the power of 4. 2 power 4, 2 to the 4 is 8, 16 we can write. And this 3 power means the power of 3 is 1 upon 2. So we can write here 3 power is 1 upon 2, and the power is 4, and then we can cancel by 2, and 2 is, so 16 multiplied by 3 power 2 is 9, so you can get the answer 16 multiplied by 9 is 144, and we got the answer. I mean, this is just for the practice. Okay, in part D, 9, 3, 6, all three are having the same basis. So what we can do here, D part, like we can write 9 as the base of 3. Like we can write 3 power is 2 is 9, and the whole power is 1 upon 3. This is already 3 power is 1 upon 3, and this we can write 2 into 3. We can factorize 2 into 3. Okay, now we can simplify. 3 power is multiply, power to power is multiplied 2 upon 3. This is 3 is 1 upon 3. This is 2 into 3. Now we are having same bases, like 3 same base, this 3 same base, this 3 same base. When there is no power, is always 1. So 3 power is 2 upon 3. Power will be added here, plus 1 upon 3. And this power 1 will be minus. And denominator we have just 2 left. This is 1. And we need to add mass, we have to use calculator, but we are doing without using calculator. So we can write 3 ones. This is 2 plus 1, and this multiplied by 3 is 3. So 3, this is 0, so it's 0. And denominator is 2. So what we can write, there's 3 power 0 upon 2, and anything having 0 power equals to 1 upon 2, and that's your answer. Okay, we can move to the next part. D part we have done. Part A, E. In E part, 25 we can write 5 power is 2. 1 upon 4. 5 power 1 upon 3, and 5 power is 1 upon 6. This 2 and we can cancel out. 2 times 1 and 2 times 2. So we have 5 power 1 upon 2 plus 1 upon 3 plus 1 upon 6. All bases the same, so we can add the power. So 5 power is 3 and 2 is 6 LCM. This is 3 plus this 3, 2, and this is 1, and 6 upon 6, and the answer is 5 power 1, that is only 5. Okay. I mean, this is a way that we can simplify. This is here, this is the 0, this is 0. So 0 is result is 1. This we can doing the F part. 3 power 1 upon 3 multiplied by 1 multiplied by 3 power, we can convert 2 and 2 upon 3, and this we can write 3 power 3 is 27, and 2 upon 3 is outside. So now we can cancel this 3 and 3 cancel out, this is there, and we can like this is the same, so we can do 3 ones. 1 upon 3 plus 2 upon 3, and this 2 will become minus 2. That 1 is there. Just practice makes man perfect. So what we can write 3 here. 3 is 1 plus 2 minus, and when I want to make it 3, this is 6. So the final answer is minus 3 upon 3, and this is minus 1. 3 power is minus 1. Normally we write positive, so 1 upon 3 is your result. We have done it. Okay. After this question number 1, this is the example of like how we can use indices here. Okay, I'm moving to question number 2. Like 2 is also like in examination we are not having this type of question, but this will also only help us how we can use substitution here, like question number 2 I'm solving. In question number 2, given that y is 2x power is 3 upon, to find y when x is 9. Okay, when x is 9 means I have to put the value here. Part A was the equation. Y is equals to 2x 3 upon 2, and I have to find y, so y is equals to there 2x is 9 and 3 upon 2. Now just simplify this. You know this. How can I make this base of 3? So this is square, and 3 upon 2, and this 2 and 2 cancel out. So don't multiply with 3. First simplify the bracket first. Then you can write 3 power 3 is 27, and 27 multiplied by 2 is your result 54, and that's your answer. I mean, this is the way you can solve it. There is no problem in A part, as well as you can do the y. To find y, we have to put the value here. Okay, I will move to the question number 3. I will not do all the part, but I think so I should do 3. Yes, 3 is a good question. What can I do here in the first part? This plus means I have to convert all the equation in 2 power x forms. Okay, can I write 2 power x into 2 power 3? Because power added means bases will be same. So can we write, and this is equals to what? Y. So y into 2 power 8. So we can write 2 power 3 is 8. 8y is your answer. We have done it. This is only to this is practice in when I convert the equation in log form. This is very important part here. Okay, when minus is there, what can I do? I can write 2 power 2x and divided by 2 power. Okay, first I can write multiply by 2 power minus 1. Okay, then what we can do? This 2 power 2x is like here is when y is equals to in question number 2, when y is equals to 2 power x, so y squared will be 2 power 2x. So this 2 power 2x is there, this is y squared. So what can I write? Y squared, and this will become upon 2, and that's we have done. This situation, like part C, I am solving here. This is question number 3. Okay, what we can do? 2 power 2 into 2 power minus x first. Okay, now we can simplify. 3 into 2 power 2 is 4. This minus x will divide 2 power x, and this is 12, and this is equals to y, and we have done it. And this is the way we can solve this, and so on. There are many you can get the idea how I solve this. Moving to question number 4. In question number 4, what I have to do? Okay, question number 4. 3 power x is y, 2 power z, x is z. I mean, there were two variables together. So this 9 you can convert into 3 into 3. Okay, I'm solving the first part. 2 this you can write 9 power x into 9 power 1 first. Then you can write 3 power 2x into 9. I told you 3x means this is y square. So y square into 9, and 9 times 2 is 18, and y square, and we have done it. Okay. This is good example, part B, because we have to use both 2x and 3x. So 6 power x minus 1, we can write what? 2 into 3, and we can write x minus 1. Or one more way, we can write 6 power x into 6 power minus 1. This is easy. Now this is what? 2 power x into, you can write like this, 2 into 3 x, and this 6 will divide. Okay, whole power is the power 2, or 2 power x into 3 power x divided by 6. 2 power x is z, and this is y divided by 6. So final answer is y z upon 6, and we have done it. This is the way we have done B part. Okay, 5 part I'm not solving. I'm moving to most important part, like question number 6 and question number 7. And please, this exercise I'm talking about here, like surds. We have this like frequent questions in O-level advanced paper. I can show you one of the question here, one paper. Yeah, this question. This is June 2008 paper 1, question number 1. This is the same example, and when I move to like here, same example. Like this is very important part. So I think so I should move to question number 5 and 6. Okay, let's see. Before that, okay, this part, question number 5, most important, please. I need your attention. Yes, yeah. Now I need your attention. Question number 6, part A, under root 18. And please, this surds, the radical, this always, please do not use calculator. We have to show all the steps here. Okay. Under root 18, this is very simple. You can use 18 like 2 times 18, 3 and 3. So you can write 2 into 3 into 3, and the pair will become out, and answer is this. Okay. Moving to question number, this was very simple. In B part, what we can do? In B part, we can write 6 into 8 together in one root, and then we can write 2 into 3 into, now this 8 will be 2 into 2 into 2, one pair, second pair. This 2 into 2 is outside, under root 3, and answer is coming 4 under root 3. This is not the big issue. Okay. C part, for this part I will discuss 2 ways to solve. First is what we can write in one root, 60 upon 5, 5 times 1 and 12. So under root 12, and then you can break 2 into 3. This is 12. So this pair, and 2 into under root 3, and that's your result. Okay, please, the most important part here now. This is, we need your attention now. I need your attention. Under root 3, under root 3, under 3. Normally the radical, the under root 3 is just behave like x, like this under root 3, suppose this under root 3 is x. So what's your question now? 2x plus 5x minus 3 under root, sorry, x. 2x, 5x. 7 minus 3 is 4x. This is like all the radicals behave like a variable, like x or y. But please do not forget this. This is very important. This radical should be behave like a variable. But what is the reason behind it? That's why we do not add or subtract radicals in subtraction or addition. What's the reason? I'm just giving you. What is common in all three? All numbers. Under root 3 is common. What is left? 2 plus 5 minus 3. So 2, 5 is 7 minus 3 is 4. So that's why the answer is 4 under root 3. Okay. but please, under root 2, okay, same radical with x and x is simplified with x and x, y and z and z, so that's why under root 2, under root 8, under root 15 we cannot simplify. But when can we convert this under root 8 into under root 2? Okay, because under root 8 we can write 2, 2 and 2. So it means we can write part E 4 under root 2 minus, we can write 2 into 2 into 2, or the admin students can write directly using calculator, write under root 8, you will get the answer to under root 2. There is no problem. And you can write 50 as like this. Okay, this pair out, 4 under root 2 minus 2 under root 2 and plus 5 under root 2. Now do we have the same radicals? Same radicals. Now we can simplify. Okay, 4 minus 2 is 2, 2 plus 5 is 7, and the answer is 7 under root 2, and that's we have done. Okay. This situation, now we are having multiplication. I would like to take okay, f. In f, what we can do, 2 bracket 2 minus under root 5 plus 5, like normal, like multiplication we have to do, like in algebra we do. Okay, 2. But one thing please here, in red, like 2 under root 3, when you want to multiply with 5 under root, suppose 2, the number outside the radical will be multiplied with outside, and inner number will be multiplied with inside. 2 5 times is 10, and this is 6. Okay, this is the normal method, just remember. 2 times 2 is 4, the 1 is here, so 2 times 1 is 2, and under root 5 is there, plus 2 times under root 5, and under root 5 multiply, you know what's the result. This 5 means 2 times 5, and 5 will come out, only 5 is left, so I will write minus 5. 4 will simplify with 5 is minus 1, and this minus 2, radical, same base radicals are there, so you can add, and there is, and that's your answer. There is nothing. But one thing, did you observe something? This is very important example. And this 2 plus under root 5, 2 minus under root 5. Okay, what is here? Please, I want to discuss something here. Okay, this is called conjugate. Conjugate is very important thing, like suppose when we have a plus b, a minus b, when we multiply, your result will be what? A square minus b square. This is called the conjugate, like here radical plus and one side, one is minus. Like what is the conjugate of, okay, I am giving an example here. What's the conjugate of 2 under root 2 minus under root 5? What's the conjugate? The conjugate will be, just change the sign, minus will become plus, plus, when plus is there, make it minus. So 2 under root 5 and plus under root 5. Sorry, this is 2. So you don't need to do the long calculation, just use the formula. What? Difference of 2 square, 2 under root 2 whole square minus under root 5 whole square. Okay, what do you mean by conjugate? Actually, the conjugate is a method to rationalize your radical. I mean, when you multiply these two radicals, this under root, these two under roots, automatically that will rationalize, means there will be no under root. Check it out. 2 square is 4, and this root cancel is only 2, and root is cancelled only 5, so 8 minus 5, and that's 3. This is called rationalize. Please, this is very important. We have number of question in examination, like you can see this example here. Here is given in this form, and there is no value in the denominator. See, I have to remove this denominator. So it means when I want to remove this denominator, I have to multiply this denominator with conjugate. Like before solving this, I just want to write only the conjugate of denominator because I don't want anything in the denominator. Okay, so it means what I have to do, I have to multiply this denominator with conjugate 4 minus 3 under root 2. But what is the method? This is normal method as when we multiply with the conjugate, I mean divide, we also here write the same because multiply divided by the conjugate. This effect will rationalize the denominator. What is the rationalization? Like just observe the denominator. 4 whole square. We don't need to do the whole calculation. There's a difference of 2 square formula. Whole square. Do not worry about the numerator. 4 square is what? 16. And 3 square is 9 into 2. Just look at the denominator. 16 minus 18. And the answer is minus 2. And then we can simplify like 8 multiply with 4 minus 3 under root 2, then minus 3 under root 2 multiply with 4 minus 3 under root 2, and we can get the answer. Okay, 8, I am just solving here. Okay, 8 times 4, 32 minus 24 under root 2, then multiply 4 with 3 is 12 under root 2, and minus is plus. 3 times 3 is 9, and radical multiply with radical same, so we just write 2 here. Okay, I just want to simplify the numerator. What's the final answer? 32 minus and 20, same radical and the same sign, so on 24, and this is 36 under root 2, and this answer is 18. Okay, 32 and 18 we can add it. This is coming 0 and 5 minus 36 under root 2. It means this is the final answer of here, this part. So can I write here? The final answer is 50 minus 36 under root 2. This denominator will divide with both the numbers, so what we can write? I am solving here. 50 divided by minus 2 and minus 36 divided by this minus 2. So final answer is minus 25, and this minus is plus. 36 divided by 2 is 18 and under 2. So it means where A and B are the integers. Integers means A is minus 25. You can see here, and under root 2 B is 18. This is the way this you can get the answer. Like in our book, like when you see our book, in our book we can simplify this. I have solved the past paper question first, but this is the same method. This we have to use. This how we can remove, rationalize is given in the question here. Rationalize the denominator. And when to rationalize the denominator, we have to multiply with the conjugate. I think so. These are the very simple examples. I would like to give first C. C is 9 divided by 2 under root 3 minus 3. I have to multiply and divide it by the conjugate to remove this. Okay, conjugate is what? Denominator. 2 under root 3, this minus will become plus. This is called the conjugate. I will write the same here. And please do not use calculator. You have to show all the steps here, about 4 marks, 3 marks. We cannot. You can verify your answer by using calculator. Okay, denominator I have to use difference of 2 square formula. And just look at the denominator. It will, like, there will be no radical sign now. 2 square is 4 and 3 is 4 into 3 minus 9, and 12 minus 9 is coming 3. Okay, 9 okay, 9 times 2, 18 under root 3, and this is 27. 18 under root 3, 27, 18 under root 3 and 27. Okay, there are two methods. You can write 3 with both or take common. So I better write 3 with both, I think so. Here 3, 27 with 3. 3 times 6 is 18 and 3 times 9 is 27. We solve part C. Okay, A part, what you can do here, you can just simplify. We don't need to use the conjugate because it's very simple, because radical 3 same, that's become on 3 and this answer is 6 under root 3, and you can simplify 2 and the answer is 2 under root 3. We don't have this type of question examination, so please, all the questions should be done the same method using conjugate. But here in E part there is a square, so what you have to do, I just want to give an example. This idea, this how can you solve a square, you have to expand it first. A square plus 2ab plus b square. When you have the final answer like 6 plus 4 under root 6 and plus 4, this is 10 plus 4 under root 6. This is the final answer in the denominator. Then you can make conjugate and you can simplify. This was about exercise 3.1 additional maths, Singapore Asian publication. So in the next I will move to the 3.2 and so on, and logarithm. There are a number of exercises. I hope that you understood this my lecture. Normally what I taught in my classes the same way I explained here. And thank you so much for watching this. Please share with your friends so that you can have, and please subscribe and like my video, and press the bell icon so that you can receive my new videos. Thank you so much and have a nice day.